What if I told you that right now, as you're watching this video, you're traveling through space at nearly 300 million meters per second, and yet you can never, ever go faster than light? What if I told you that this isn't just a rule of physics? It's literally the fabric of reality itself, and breaking it wouldn't just be impossible. It would unravel the very concept of cause and effect. Here's something that will absolutely blow your mind. Einstein didn't discover the speed of light limit because he was studying light. He discovered it because he was trying to figure out why a simple magnet behaves the way it does. And what he found changed everything we thought we knew about time, space, and reality itself. But here's the kicker, and this is where your brain is about to explode. The speed of light isn't actually about light at all. It's about the maximum speed that information can travel through the universe. Light just happens to be the messenger we noticed first. If you're ready to have your understanding of reality completely reconstructed, smash that like button, subscribe for more mind-bending physics, and let me know in the comments what country you're watching from and what time it is where you are, because by the end of this video, you'll understand why even time itself isn't what you think it is. Let's start with something that seems simple, but will break your brain. You're sitting there watching this video, thinking you're stationary, right? Wrong. You're currently moving at about 30 kilometers per second around the sun. The sun is moving at 220 kilometers per second around the galaxy. Our galaxy is moving at 600 kilometers per second through space. Add it all up, and you're racing through the universe at incredible speeds right now. But here's what's absolutely insane. Despite all this motion, light always moves at exactly 299,792,458 meters per second relative to you. Always. No matter how fast you're moving, no matter what direction you're going, light always passes you at the same speed. Think of it like this. Imagine you're on a train going 100 kilometers per hour, and another train passes you going 150 kilometers per hour. From your perspective, that train is only going 50 kilometers per hour faster than you. But light doesn't work this way. If you're on a spaceship going 99% the speed of light, and someone shines a flashlight past you, that light still passes you at the full speed of light, not 1% the speed of light, like you'd expect. This is where James Clerk Maxwell comes in. In 1862, this Scottish physicist was working on electromagnetic equations and discovered something shocking. His math predicted that electromagnetic waves, including light, must travel at a specific speed through empty space. Not up to a certain speed, not usually a certain speed, but exactly one speed, always. Maxwell had no idea he'd just uncovered the fundamental speed limit of the universe. He thought he'd just figured out how light works. But what he'd actually discovered was that space and time themselves have a built-in speed limit, and light just happens to travel at that maximum speed. Here's where it gets mind-bending. In 1887, Albert Michelson and Edward Morley performed what's now called the most important failed experiment in history. They were trying to measure Earth's movement through something called the luminiferous ether, a substance they thought light waves traveled through, like sound waves travel through air. They set up an incredibly precise experiment using mirrors and light beams, expecting to see light travel at different speeds as Earth moved through this ether. But no matter how they oriented their equipment, no matter what time of year they performed the experiment, light always traveled at the same speed in all directions. The experiment failed because it didn't detect the ether. But what it actually did was prove something far more profound, that the speed of light is constant for all observers, regardless of their motion. This wasn't just surprising. It was reality-shattering. But here's what will truly blow your mind. This constant speed isn't just a property of light. It's a property of space-time itself. It's the speed at which causality propagates through the universe. It's the speed at which now becomes then. Light just happens to travel at this cosmic speed limit because photons have no mass. And here's the shocking implication that we'll explore throughout this video. This speed limit doesn't just affect objects moving through space. It affects time itself. It affects the very structure of reality. And it means that faster than light travel wouldn't just be like going really fast. It would literally allow you to arrive before you left. Now here's where a young patent clerk named Albert Einstein comes in and absolutely destroys everything we thought we knew about reality. In 1905, at just 26 years old, Einstein published a paper that would change physics forever. But here's what's incredible. He wasn't even trying to study the speed of light. Einstein was obsessed with a simple question. Why does a magnet only work when it's moving? If you hold a magnet near a wire, nothing happens. But move the magnet, and electricity flows through the wire. Move the wire instead, and you get the same result. But according to the physics of the time, these should be completely different phenomena. Einstein realized that the laws of physics must look the same whether you're moving or standing still. This seems obvious, but it had profound implications. If the laws of physics are the same in all reference frames, and if Maxwell's equations about light are laws of physics, then the speed of light must be the same for everyone, regardless of how fast they're moving. But wait, this creates a massive logical problem. If I'm moving toward a light source at half the speed of light, common sense says the light should appear to be moving toward me at 1.5 times the speed of light. But if the speed of light is constant, it must still appear to move at exactly the speed of light from my perspective. Einstein's brilliant insight was that something else must change to keep light's speed constant, and that something is space and time themselves. This is special relativity, and it's about to blow your mind. Think of it like this. Imagine space-time as a fabric that can stretch and compress. When you move very fast, this fabric stretches in the direction of your motion, making distances contract, and it also stretches time, making clocks run slower. These changes happen in precisely the right way to ensure that light always travels at the same speed from your perspective. Here's the mathematical proof that will make your brain hurt in the best way. Einstein showed that if you're moving at velocity v, time dilates by a factor of 1, divided by the square root of 1v squared per c squared, where c is the speed of light. Notice what happens as v approaches c. The denominator approaches 0, which means time dilation approaches infinity. Time literally stops at the speed of light. But here's the truly mind-bending part. Length also contracts by the same factor. An object moving at 99%, the speed of light would appear to be compressed to about 14% of its original length in the direction of motion. At the speed of light, length would contract to 0. This isn't just theory. We've measured it. In 1971, Haffel and Keating put atomic clocks on airplanes and flew them around the world. When they compared these clocks to identical ones that stayed on the ground, they found exactly the time difference Einstein predicted. Time really does slow down when you move fast. But here's what will absolutely blow your mind. You can't just gradually speed up to the speed of light. As you approach light speed, your mass effectively increases toward infinity. The energy required to accelerate you further also approaches infinity. It would take infinite energy to accelerate any object with mass to the speed of light. This is why nothing with mass can reach the speed of light. It's not like hitting a wall. It's like the wall keeps moving away from you the closer you get to it. The speed of light isn't just fast. It's the speed at which massless particles must travel through spacetime. And here's the kicker that sets up everything we'll explore next. This speed limit isn't just about motion through space. It's about the fundamental structure of spacetime itself. Breaking it wouldn't just mean going really fast. It would mean breaking causality, the basic principle that causes must come before effects. What if I told you that the speed of light limit exists because space and time aren't actually separate things? What if the reason nothing can go faster than light is because light speed is the speed at which space and time are connected? Here's where Hermann Minkowski, Einstein's former mathematics professor, comes in with an insight that will completely rewire your understanding of reality. In 1908, Minkowski realized that Einstein's relativity could be understood geometrically. Space and time aren't separate dimensions. They're part of a single four-dimensional fabric called spacetime. Think of it like this. Imagine you're walking across a field and someone asks how far you traveled. Well, that depends on your path. You might walk 100 meters north and 100 meters east, traveling 200 meters total, but ending up only 141 meters from your starting point, thanks to the Pythagorean theorem. In spacetime, something similar happens with space and time. But here's the mind-bending part. In spacetime, the geometry is twisted. Instead of the familiar Euclidean geometry, where the shortest distance between 2 points is a straight line, spacetime uses what's called Minkowski geometry. In this geometry, time has a negative sign compared to space dimensions. This mathematical quirk has profound physical consequences. In normal space, if you move faster, you cover more distance. But in spacetime, if you move faster through space, you must move slower through time. The total distance through spacetime, called the spacetime interval, remains constant. Here's the equation that will blow your mind. ds equals c squared dt squared plus dx plus dy squared plus dz. This describes the geometry of spacetime itself. Notice that c, the speed of light, isn't just a speed here. It's a conversion factor between space and time. It's literally built into the geometry of reality. This means that everything, including you right now, is always moving through spacetime at exactly the speed of light. Always. You're just dividing that motion between space and time. When you're sitting still in space, all your motion through spacetime is motion through time. When you move through space, some of that motion gets redirected from time to space. But here's what's absolutely incredible. Photons of light have no mass, which means they don't experience time at all. From a photon's perspective, it travels from the sun to your eye instantaneously. The 8 minutes we measure for light to travel from the sun to Earth is only from our perspective. To the photon, no time passes at all. This is why nothing can go faster than light, because the speed of light isn't really about light. It's the speed at which any massless information travels through spacetime. It's the speed at which causality propagates. It's the conversion rate between space and time. But here's where it gets truly mind-bending. The speed of light is also the speed at which the future becomes the past. It's the speed at which possibilities collapse into actualities. When we say nothing can go faster than light, we're really saying nothing can outrun causality itself. And this leads us to perhaps the most shocking implication. If you could somehow go faster than light, you wouldn't just arrive somewhere quickly. You would literally arrive before you left. You would violate causality and create grandfather paradoxes, not with time travel, but just with faster than light motion. Here's a thought experiment that will break your brain. Imagine two observers moving toward each other at high speed. Each sees the other's clock running slow due to time dilation. If one of them could somehow signal the other at faster than light speed and receive a faster than light response, they could receive the response before they sent the original signal. Faster than light communication is equivalent to time travel. Now here's where things get absolutely insane, and I guarantee this will blow your mind. We've been talking about the speed of light as a limit, but quantum mechanics reveals something even more bizarre. Particles can actually influence each other instantaneously across any distance. So does this break the speed of light limit? The answer will shock you. This phenomenon is called quantum entanglement, and it was so disturbing to Einstein that he called it spooky action at a distance. When two particles become entangled, measuring one instantly affects the other, no matter how far apart they are. In 1982, Alling Aspect performed experiments that proved this was real. Quantum entanglement really does happen instantaneously. But here's the twist that will make your brain hurt. even though entangled particles influence each other instantly. You can't use this to send information faster than light. Here's why. When you measure an entangled particle, you get a random result. The other particle's measurement will be correlated with yours, but the person measuring it has no way to know what correlation to expect without you telling them through normal, slower-than-light communication. Think of it like this. Imagine you have two coins that always land on opposite sides when flipped simultaneously, no matter how far apart they are. If yours lands heads, you know the other landed tails. But the person with the other coin just sees tails. They have no way to know that yours landed heads unless you call them and tell them. The correlation is instant, but the information transfer still requires normal communication. This reveals something profound about the speed of light limit. It's not just about matter or energy. It's about information and causality. Quantum entanglement doesn't violate the speed of light limit because it doesn't allow faster-than-light information transfer. But here's what's truly mind-bending about this. It shows us that reality at the quantum level is non-local. The universe doesn't seem to be made of separate, independent parts. Instead, it appears to be one interconnected whole, where distant parts can share states instantaneously, even though they can't communicate instantaneously. This connects to something even more profound about the speed of light. In quantum field theory, developed by physicists like Richard Feynman in the 1940s, particles are understood as excitations in quantum fields that fill all of space. These fields can only propagate changes at the speed of light or slower. Here's the shocking revelation. What we call empty space isn't empty at all. It's filled with quantum fields fluctuating at the speed of light. The speed of light limit exists because these quantum fields are the fundamental substrate of reality, and they can only carry information at light speed. This means that when we say nothing can go faster than light, we're really saying that nothing can outrun the fundamental updates of reality itself. The universe operates like a cosmic computer, processing information at the speed of light, and that processing speed is the ultimate speed limit. But here's what will absolutely blow your mind. This suggests that space and time themselves might be emergent properties of something even more fundamental. Some cutting-edge theories suggest that spacetime arises from quantum entanglement networks, and the speed of light emerges from the way these networks process information. This is where the story gets really wild, because it suggests that the speed of light isn't just a speed limit, it's the refresh rate of reality itself. The universe is constantly updating at light speed, and nothing can go faster, because there is no faster. Light speed is as fast as reality can happen. Here's something that will completely shatter your understanding of the universe. The speed of light isn't just a random number. It's precisely the right value to make chemistry possible, to make stars shine, and to make life exist. Change it by even a small amount, and the universe becomes completely different and probably lifeless. This is where we encounter one of the most profound mysteries in physics. Why does the speed of light have the value it has? At 299,792,458 meters per second, it seems arbitrary. But this number determines the strength of electromagnetic forces, the stability of atoms, and the evolution of the universe itself. Here's the mind-bending reality. If the speed of light were much faster, atoms couldn't hold together. The electromagnetic force would be too weak compared to other forces. If it were much slower, atoms would collapse under electromagnetic attraction. The speed of light sits in a narrow range that makes matter stable. But it gets even more incredible. The speed of light determines how fast stars can shine. Nuclear fusion in stars depends on the balance between electromagnetic repulsion and nuclear attraction, and this balance is set by the speed of light. Change the speed of light, and stars either burn out instantly or never ignite at all. This connects to something called the fine structure constant, discovered by Arnold Sommerfeld in 1916. This number, approximately 1/137th, describes the strength of electromagnetic interactions and is directly related to the speed of light. Wolfgang Pauli, one of the founders of quantum mechanics, was so obsessed with this number that he believed it held the key to understanding the universe. Here's what's absolutely incredible about this number. It has no units. It's the same whether you measure it in meters per second, miles per hour, or any other units. It's a pure number that describes the fundamental structure of reality, and nobody knows why it has the value it does. But here's where it gets truly mind-bending. The fine structure constant determines how fast electrons orbit atomic nuclei compared to the speed of light. If this number were much different, atoms would behave completely differently. Chemistry, as we know it, couldn't exist, and neither could life. This leads to what physicists call the anthropic principle, the idea that the fundamental constants of physics, including the speed of light, have the values they do because those are the only values compatible with the existence of observers like us. It's as if the universe fine-tuned itself for complexity in life. But here's an alternative that will blow your mind even more. What if there are infinitely many universes with different values for the speed of light, and we exist in this one simply because we couldn't exist in the others? This is the multiverse hypothesis, and it suggests that our universe's speed of light is just one possibility among infinite possibilities. Think about this for a moment. In universes where the speed of light is much different, there might be no atoms, no stars, no planets, and no life. We exist in this universe precisely because its speed of light allows us to exist. The speed of light limit isn't just a physical law, it's a prerequisite for our existence. Here's another mind-bending possibility. Some theories suggest that the speed of light might not be truly constant across all of space and time. There's some evidence that the fine structure constant might have been slightly different in the early universe, which would mean the speed of light was different too. If true, this would mean the universe has been evolving, not just in its contents, but in its fundamental laws. The speed of light limit might be like a cosmic thermostat, settling into the value that allows maximum complexity and information processing. This connects to cutting-edge ideas about the universe as an information processing system. If the universe is fundamentally about information, then the speed of light is the processing speed of cosmic computation. And that processing speed determines what kinds of complex structures, like stars, planets, and living things, can emerge. What if I told you that faster-than-light travel wouldn't just be really fast transportation? It would literally break the logical structure of the universe. Here's where we dive into the most mind-bending consequences of the speed of light limit, and why violating it would create paradoxes that would make time travel seem simple. Let's start with something called the relativity of simultaneity, one of the most brain-breaking concepts in physics. Here's the setup that will blow your mind. Events that appear simultaneous to one observer don't appear simultaneous to another observer moving at high speed. This isn't just a measurement problem. Simultaneity literally doesn't exist as a universal concept. Imagine two lightning bolts strike the ground simultaneously, as measured by someone standing still. But to someone speeding past in a spaceship, one lightning bolt strikes before the other. Not because light takes different amounts of time to reach them, but because simultaneity itself is relative to motion. Now here's where faster-than-light travel creates an absolute catastrophe for causality. Imagine you're on Earth and you send a faster-than-light signal to a spaceship speeding away from you. From your perspective, the signal travels forward in time. But from the spaceship's perspective, due to the relativity of simultaneity, that same signal travels backward in time. If the spaceship immediately sends a faster-than-light signal back to you, it could arrive on Earth before you sent the original signal. You could literally receive a response to a message you haven't sent yet. This isn't science fiction. It's the inevitable mathematical consequence of faster-than-light communication in Einstein's universe. Here's an even more mind-bending example. Imagine you have a faster-than-light telephone. You call your friend on a planet 10 light-years away. From your perspective, you're having a normal conversation. But now imagine both of you are moving toward each other at 90% the speed of light. Due to time dilation and the relativity of simultaneity, you could call your friend and reach them yesterday. They could call you back and reach you the day before that. This creates what physicists call closed time-like curves, paths through spacetime that loop back on themselves. You could have a conversation with yourself in the past, create grandfather paradoxes, or even prevent your own birth. Faster-than-light travel isn't just about speed, it's about causality violation. But here's what's absolutely incredible. The universe seems to conspire to prevent these paradoxes. Every time physicists have proposed a mechanism for faster-than-light travel, they've discovered that something prevents it. It's as if the universe has built-in safeguards against causality violation. Take wormholes, for example. These theoretical shortcuts through spacetime were popularized by Kip Thorne's work in the 1980s. Mathematically, wormholes could allow faster-than-light travel by taking a shortcut through higher dimensional space. But every realistic wormhole model requires something called exotic matter, with negative energy density to keep the wormhole open. Here's the kicker. Exotic matter probably doesn't exist. And even if it did, Stephen Hawking proved that quantum effects would likely destroy any wormhole the moment you tried to send information through it. The universe seems to actively prevent faster-than-light communication. The same thing happens with every other faster-than-light scheme. The Alcubierre warp drive, proposed by Miguel Alcubierre in 1994, could theoretically allow faster-than-light travel by contracting space in front of a spacecraft and expanding it behind. But it requires exotic matter with impossible properties, and quantum effects would probably destroy it. Even quantum entanglement, which allows instantaneous correlations across space, can't be used for faster-than-light communication. Every attempt to use entanglement for communication either fails or requires slower-than-light classical communication to complete the information transfer. Here's the profound truth. The speed of light limit isn't just a speed limit. It's a causality preservation mechanism. It's the universe's way of ensuring that cause comes before effect, that information can't travel to its own past, and that logical paradoxes don't tear apart the fabric of reality. This connects to something even deeper. The speed of light might be the speed at which logic itself propagates through the universe. Faster-than-light travel wouldn't just be physically impossible, it would be logically impossible, like creating a stone so heavy that an omnipotent being couldn't lift it. Now let's talk about something that will absolutely blow your mind. What actually happens to matter as it approaches the speed of light? We've talked about time dilation and length contraction, but there's something even more mind-bending happening. The energy required to go faster increases toward infinity. Here's the equation that will make your brain hurt. E equals mc square root 1v squared per c squared. This is the full relativistic energy equation, and it reveals something shocking. As your velocity v approaches the speed of light c, the denominator approaches zero, which means your energy approaches infinity. Think about what this means. To accelerate a single electron to the speed of light would require infinite energy. Not just all the energy in the universe, literally infinite energy. This is why particle accelerators, the most powerful machines humans have ever built, can only get particles to 99.9999% the speed of light, never quite reaching it. But here's what's truly mind-bending. This isn't just about running out of fuel. As you approach the speed of light, your relativistic mass increases toward infinity. From the perspective of someone watching you, you become infinitely massive right at light speed. Your gravitational field would become infinite. You would collapse into a black hole, and space-time itself would be torn apart. Let me give you some numbers that will blow your mind. The Large Hadron Collider, the most powerful particle accelerator ever built, accelerates protons to 99.9999991% the speed of light. At this speed, Each proton has the same energy as a flying mosquito, concentrated into a space trillions of times smaller. The energy density is so extreme that when these protons collide, they recreate conditions that existed in the first moments after the Big Bang. But even at this incredible speed, the protons are still traveling about 3 meters per second slower than light. To close that final gap would require more energy than exists in the observable universe. This isn't an engineering problem. It's a fundamental feature of reality. Here's something even more incredible. This energy barrier exists because mass and energy are the same thing, as revealed by Einstein's famous E equals mc. But the full story is even more profound. Mass is actually just energy that's been frozen into matter. When particles move at high speeds, their kinetic energy contributes to the relativistic mass. This connects to something absolutely mind-blowing about the nature of mass itself. Most of the mass in your body doesn't come from the particles that make up your atoms. About 99% of your mass comes from the binding energy that holds quarks together inside protons and neutrons. You are literally made of frozen energy. But here's where it gets truly weird. Massless particles, like photons, must travel at exactly the speed of light. They can't go slower, and they can't go faster. They exist in a kind of liminal state where they experience no time and have no rest frame. From a photon's perspective, it's created and absorbed in the same instant, regardless of how far it travels. This reveals something profound about the speed of light. It's not just the maximum speed for matter, it's the only speed for massless energy. The speed of light is the speed at which pure information travels through the universe. Matter can approach this speed, but never reach it, while pure energy must travel at this speed and can never deviate from it. Here's a thought experiment that will break your brain. Imagine you're in a spaceship approaching the speed of light. From your perspective, you feel completely normal. Your clocks tick normally, your rulers measure normal lengths, and you don't feel like you're moving at all. But if you look outside, the entire universe appears compressed in the direction of your motion, and time in the outside universe appears to be running extremely fast. As you get closer and closer to light speed, the universe in front of you would appear to compress into a smaller and smaller region directly ahead of you. Eventually, the entire visible universe would appear as a bright ring of light surrounding you, and the rest of the universe would be invisible behind you. But here's the kicker. You could never actually reach light speed, no matter how much energy you have. The energy barrier becomes infinite, and the universe conspires to prevent you from ever breaking the speed of light limit. It's as if reality has built-in protection against causality violation. Here's something that will completely blow your mind about the speed of light. It's intimately connected to consciousness and observation in ways that challenge our deepest assumptions about reality. The speed of light isn't just about physics. It's about the fundamental relationship between observer and observed. Let's start with something absolutely mind-bending. The concept of simultaneity depends on the observer. Events that happen at the same time for one observer happen at different times for another observer moving at high speed. This isn't just a measurement problem. Simultaneity literally doesn't exist as an objective feature of reality. Think about what this means for consciousness and awareness. Your sense of now, this present moment you're experiencing while watching this video, is not universal. An observer moving past Earth at high speed would have a completely different now that includes events in your future and excludes events you consider to be happening right now. This connects to something called the block universe theory, which suggests that all of spacetime, past, present, and future, exists simultaneously in a four-dimensional block. What we experience as the flow of time is just our consciousness moving through different slices of this eternal structure. But here's what's truly mind-bending. The speed of light determines how these different slices of time are arranged. The light cone structure of spacetime, with the speed of light as the boundary, determines what events can causally influence each other and what events are simultaneous for different observers. Here's a thought experiment that will break your brain. Imagine you have perfect knowledge of the state of the entire universe right now. Due to the relativity of simultaneity, right now for you includes events that are in the future for someone moving toward you, and events that are in the past for someone moving away from you. Your now slice through space-time includes what others would consider the future. This suggests something absolutely incredible about consciousness and the speed of light. Your awareness is fundamentally limited by light-speed causality. You can only be directly aware of events within your past light cone, events that could have causally influenced your current state. But here's where it gets even weirder. Quantum mechanics suggests that observation plays a fundamental role in determining reality. The active measurement seems to collapse quantum superpositions and determine which of many possible realities becomes actual. And this process is also limited by the speed of light. When you observe a quantum system, the information about your measurement can only propagate at light speed. This means that the universe becomes real in a spreading sphere around each observation, expanding at the speed of light. Reality might literally be constructed by conscious observation, spreading outward at the cosmic speed limit. This connects to something called the measurement problem in quantum mechanics, the question of when and how quantum superpositions collapse into definite states. Some interpretations suggest that consciousness plays a role in this collapse, and if so, the speed of light determines how quickly conscious observation can make the universe real. Here's another mind-bending possibility. Some theories suggest that space-time itself emerges from quantum entanglement networks. If consciousness is somehow connected to quantum processes, then the speed of light might be the rate at which conscious awareness can influence the structure of space-time. Think about this. When you make a conscious decision, that decision can only influence events within your future light cone. Your free will, if it exists, is fundamentally limited by the speed of light. You can only causally affect events that light could reach starting from your current location. But here's what's truly profound. This limitation might be what makes free will possible in the first place. If information could travel faster than light, then every event in the universe would be causally connected to every other event. There would be no room for genuine choice or random quantum events. The speed of light limit creates islands of causality where genuine novelty can emerge. This suggests that consciousness, free will, and the speed of light are intimately connected. The cosmic speed limit doesn't just constrain matter and energy. It constrains information, causality, and perhaps consciousness itself. Your awareness is fundamentally a light-speed phenomenon. Here's one more mind-bending idea. Some physicists suggest that the universe is fundamentally computational, processing information at the speed of light. If consciousness is an information processing phenomenon, then the speed of light is the ultimate processing speed of mind itself. Your thoughts, decisions, and awareness all happen at or below the cosmic speed limit. Now let's bring this home to you personally, because here's something that will absolutely blow your mind. The speed of light isn't just an abstract physics concept. It's actively shaping your life, your relationships, and your consciousness right now in ways you've never imagined. Every single experience you've ever had has been fundamentally limited by the speed of light. When you look at the stars at night, you're not seeing them as they are now. You're seeing them as they were years, decades, or centuries ago. The light from the nearest star takes over 4 years to reach your eyes. You're literally looking into the past every time you gaze at the night sky. But here's what's truly mind-bending about your personal experience. Even when you look at your own hand, you're seeing it as it was about 4 nanoseconds ago. That's how long it takes light to travel from your hand to your eyes. You have never, ever seen the present moment. Everything you've ever perceived has been the past, limited by the speed of light. Think about what this means for human connection. When you look into someone's eyes and feel that instant connection, you're actually seeing them as they were billionths of a second ago. When you hear their voice, you're hearing them as they were milliseconds ago, since sound travels much slower than light. True simultaneity in human experience doesn't exist. We're all living slightly in each other's past. Here's something even more profound. Your consciousness itself might be fundamentally limited by light-speed information processing. Neural signals in your brain travel at about 120 meters per second, incredibly slow compared to light speed. But the quantum processes that might underlie consciousness could be limited by the speed of light itself. This means that your thoughts, your decisions, and your awareness all unfold within the light speed constraint of causality. When you make a decision, that decision propagates through your nervous system at biological speeds. But the quantum information that might comprise consciousness can't exceed light speed. But here's where it gets personal, in a way that might change how you see your place in the universe. You are literally made of light speed information. The electromagnetic forces that hold your atoms together propagate at light speed. The chemical bonds that make your molecules are light speed phenomena. The electrical activity in your brain that creates your thoughts is fundamentally an electromagnetic light speed process. You are not separate from the cosmic speed limit. You are an expression of it. Your existence is possible because the speed of light has precisely the value it does. If light traveled much faster or slower, the chemistry that makes life possible couldn't exist. You are literally fine-tuned to the cosmic speed limit. Here's something that will blow your mind about your relationship to the universe. You are constantly exchanging photons with everything around you. The light bouncing off the screen and entering your eyes has traveled at the cosmic speed limit to bring you this information. You are literally connected to everything you see through light speed communication. Every color you perceive, every image that forms in your mind, every visual memory you have, all of it came to you at exactly 299,792,458 meters per second. The sunset that moved you to tears, the face of someone you love, the first time you saw the ocean. All these experiences were delivered to your consciousness at the speed of light. But here's what's truly profound. You're also constantly radiating light. Your body temperature of about 37 degrees Celsius means you're glowing in infrared light, sending photons out into the universe at light speed. These photons carry information about you, your temperature, your chemical composition, your biological state, out into the cosmos at the ultimate speed limit. Think about this right now. Photons that bounced off you years ago are traveling through space, carrying information about who you were then. If aliens with powerful enough telescopes were watching from distant stars, they could see you as you were in the past. You are literally leaving a light-speed trail of information throughout the universe. Here's something even more mind-bending about your personal connection to light speed. Every emotion you feel, every thought you think, every memory you form involves electromagnetic processes in your brain that are constrained by the speed of light. Love, fear, joy, wonder. All of these experiences are fundamentally light-speed phenomena. When you fall in love, part of what you're experiencing is a cascade of electrochemical signals racing through your nervous system. These signals are electromagnetic in nature, and they're ultimately limited by the speed of light. Your capacity for love is literally connected to the cosmic speed limit. Here's something that might change how you think about death and mortality. The light that has bounced off you throughout your lifetime will continue traveling through space long after you're gone. In a very real sense, information about you will persist in the universe, traveling at light speed through the cosmos for billions of years. Some of the photons from your childhood are now light years away from Earth, carrying images of who you were decades ago. Future civilizations might someday detect these photons and reconstruct scenes from your life. Your existence is being written in light across the universe, traveling at the cosmic speed limit. But here's what's most profound about your relationship to the speed of light. It connects you to the fundamental structure of reality itself. You're not just living in a universe with a speed limit. You're living as an expression of that speed limit. Your consciousness, your experiences, your relationships, and your existence are all manifestations of light-speed causality. Now here's where things get absolutely mind-bending in ways that will challenge everything you think you know about reality. Modern quantum mechanics has revealed that the speed of light isn't just a speed limit. It's intimately connected to the fundamental structure of space, time, and information itself. Let's start with something that will blow your mind: virtual particles. According to quantum field theory, empty space isn't empty at all. It's teeming with pairs of particles that pop into existence and annihilate each other so quickly that they can't be directly observed. These virtual particles exist for time periods shorter than what's allowed by Heisenberg's uncertainty principle. But here's the kicker. These virtual particles can only exist for times inversely proportional to their energy, and they can only travel distances limited by the speed of light. The vacuum of space is constantly crackling with quantum activity, all of it constrained by the light speed limit. The speed of light determines the very structure of quantum vacuum. Werner, Heisenberg's uncertainty principle, states that you can't simultaneously know both the position and momentum of a particle with perfect precision. But there's another uncertainty principle that's even more mind-bending: the energy-time uncertainty principle. This says you can borrow energy from the vacuum for very short periods of time, as long as you pay it back quickly enough. Here's what's absolutely incredible. The speed of light determines how far these borrowed energy particles can travel before they have to pay back their energy debt. Virtual photons can travel farther than virtual massive particles because they travel at light speed. The structure of electromagnetic fields is determined by light-speed virtual photon exchange. This connects to something that will absolutely blow your mind: the Casimir effect, discovered by Hendrik Casimir in 1948. When you place two metal plates very close together in a vacuum, they experience an attractive force due to the quantum vacuum. The space between the plates excludes certain virtual particles, creating a pressure difference that pushes the plates together. This effect has been measured and verified. The quantum vacuum really does exert forces on matter, and the strength of this force depends on the speed of light. Change the speed of light, and you change the Casimir effect, which would change the stability of matter itself. But here's where quantum mechanics reveals something truly profound about light speed. It's not just about particles moving through space. It's about the fundamental way information propagates through quantum fields that fill all of space. When a quantum field is disturbed, that disturbance can only propagate at light speed or slower. This is where quantum field theory becomes absolutely mind-bending. What we call particles are actually excitations in quantum fields. An electron isn't a little ball, it's a ripple in the electron field. A photon isn't a particle of light, it's a ripple in the electromagnetic field. And all these ripples propagate at or below the speed of light. Here's something that will break your brain. When particles interact, they do so by exchanging virtual particles. But these virtual particles must respect the speed of light limit. This means that all forces in nature, electromagnetic, weak nuclear, and strong nuclear, are mediated by particles that can't exceed light speed. Even gravity, according to Einstein's general relativity, propagates at exactly the speed of light. Gravitational waves, ripples in spacetime itself, travel at light speed. When massive objects accelerate, they create disturbances in spacetime that spread outward at the cosmic speed limit. This was spectacularly confirmed in 2015 when LIGO detected gravitational waves from merging black holes. These waves had traveled over 1 billion light-years at exactly light speed before reaching Earth. Space and time themselves ripple at the cosmic speed limit. But here's what's truly mind-bending about quantum mechanics and light speed. Quantum entanglement creates correlations that seem to propagate instantly, But quantum field theory shows that no information actually travels faster than light. The correlations are real and instantaneous, but they can't be used to send messages. This reveals something profound about the nature of reality. The universe is fundamentally non-local. Distant parts can be instantly correlated, but still respects causality. No information travels faster than light. This is one of the deepest mysteries in modern physics. Here's a thought experiment that will blow your mind. Imagine the entire universe as a vast quantum computer, with quantum fields serving as the processing medium. The speed of light would then be the fundamental processing speed of this cosmic computer. Reality itself is being computed at light speed. Some cutting-edge theories suggest that this might be literally true, that space and time emerge from quantum information processing, and the speed of light is the maximum rate at which the universe can process information. We might be living inside a cosmic computation running at light speed. What if I told you that there might actually be ways around the speed of light limit, not by going faster than light, but by bending the rules of spacetime itself? Here's where theoretical physics gets absolutely wild, exploring ideas that sound like science fiction, but are grounded in serious mathematical analysis. Let's start with something that will blow your mind, the Alcubierre warp drive, proposed by physicist Miguel Alcubierre in 1994. Instead of accelerating through space, this hypothetical drive would contract space in front of a spacecraft and expand space behind it. The spacecraft itself never exceeds light speed locally, but it could effectively travel faster than light by riding a wave of distorted spacetime. Think of it like this. Imagine you're on a moving walkway that's moving faster than you can run. You're not running faster than your maximum speed, but you're covering ground faster than normal because the walkway is carrying you. An Alcubierre drive would be like a walkway made of spacetime itself. But here's the catch that brings us back to reality. This drive would require exotic matter with negative energy density to create the spacetime distortion. We've never observed such matter, and quantum field theory suggests it might be impossible to create in the quantities needed. The universe seems to protect its speed limit, even from clever spacetime manipulation. Here's another mind-bending possibility: traversable wormholes, theoretical shortcuts through spacetime that could connect distant regions of the universe. If such wormholes existed, you could step through one and instantly emerge light years away, effectively traveling faster than light without actually exceeding light speed locally. Kip Thorne and his colleagues showed in the 1980s that traversable wormholes are mathematically possible in Einstein's general relativity. And this is a big, but they would require the same exotic matter as Alcubierre drives to keep them open. And even then, Stephen Hawking proved that quantum effects would likely destroy any wormhole the moment you tried to use it. But here's what's truly mind-bending about these theoretical loopholes. They all run into the same fundamental problem. Every attempt to circumvent the speed of light limit either requires impossible, exotic matter or creates causality paradoxes that the universe seems designed to prevent. This suggests something profound. The speed of light limit isn't just a law of physics, it's a logical necessity. The universe appears to have built-in protection mechanisms that prevent causality violation. It's as if reality has an immune system against paradoxes. Here's another fascinating theoretical possibility: shortcuts through higher dimensional space. If our three-dimensional space is embedded in a higher dimensional reality, you might be able to take shortcuts through these extra dimensions, like cutting across the inside of a sphere instead of traveling around its surface. String theory and other advanced physics theories suggest that extra dimensions might exist, curled up at every point in space at incredibly small scales. If you could access these dimensions, you might be able to travel between distant points in our normal space faster than light could travel through normal space. But here's the kicker: even if extra dimensions exist, accessing them would likely require energies far beyond what's possible with known physics. And even then, Any such travel would probably still be limited by the speed of light in the higher dimensional space. Here's one more mind-bending possibility: quantum teleportation. We've already achieved this with individual particles, instantly transferring the quantum state of one particle to another particle far away. But this doesn't involve moving matter faster than light. It involves transferring information, and classical information still needs to be sent at light speed to complete the teleportation. Even if we could scale quantum teleportation up to macroscopic objects, it wouldn't violate the speed of light limit. You'd be destroying an object at one location and recreating it at another location. But the information needed to recreate it would still travel at light speed or slower. Here's what's absolutely incredible about all these theoretical loopholes. They show us just how fundamental the speed of light limit really is. Every attempt to circumvent it either fails due to practical impossibilities or reveals that the apparent faster than light travel isn't really faster than light at all. This suggests that the speed of light isn't just a speed limit for matter and energy. It's a speed limit for causality, information, and logic itself. The universe seems to be structured in such a way that causality paradoxes are impossible, and the speed of light limit is the mechanism that ensures this. Here's something that will absolutely blow your mind about the speed of light. It's not just affecting small-scale physics and individual particles. It's shaping the largest structures in the universe, determining how galaxies form, how the universe evolves, and even setting limits on how complex the cosmos can become. Let's start with something mind-bending: the cosmic horizon. Because light has a finite speed, and the universe has a finite age of about 13.8 billion years, there's a limit to how far we can see. The observable universe has a radius of about 46.5 billion light years, larger than 13.8 billion light years due to cosmic expansion. And beyond that horizon, we literally cannot receive any information. But here's what's truly incredible. This horizon isn't just an observational limit, it's a causal limit. Events beyond the cosmic horizon cannot have any causal effect on us, and we cannot have any causal effect on them. The speed of light has divided the universe into causally disconnected regions. This has profound implications for the structure of the universe. When we look at the cosmic microwave background radiation, the afterglow of the Big Bang, we see regions that appear to have the same temperature even though they're so far apart that light hasn't had time to travel between them since the Big Bang. This is called the horizon problem, and it suggests that either the universe underwent a period of faster-than-light expansion, called inflation, or there's something we don't understand about the early universe. Either way, the speed of light is key to understanding cosmic structure. Here's something even more mind-bending: dark energy. About 68% of the universe consists of this mysterious substance that's causing cosmic expansion to accelerate. Dark energy appears to have a constant density throughout space, and as space expands, more dark energy appears, driving expansion even faster. But here's the kicker: information about dark energy can only propagate at light speed. This means that different regions of the universe learn about cosmic acceleration at different rates. The universe's expansion history is written in light speed information propagation. This connects to something absolutely incredible about galaxy formation. In the early universe, matter was almost perfectly smooth, with tiny density fluctuations of only about 1 part in 100,000. These tiny fluctuations grew under gravitational attraction to eventually form galaxies and galaxy clusters. But gravity waves propagate at light speed, which means gravitational information can only travel so fast. This sets a fundamental limit on how quickly cosmic structures can form and how large they can grow. The speed of light doesn't just constrain motion, it constrains the evolution of cosmic structure itself. Here's a thought experiment that will break your brain. Imagine if the speed of light were much slower. Gravity waves would propagate slowly, making it harder for cosmic structures to form. Stars would be dimmer, because nuclear fusion depends on electromagnetic forces, which are governed by light speed. The entire universe would be darker and less structured. Conversely, if the speed of light were much faster, electromagnetic forces would be stronger, making atoms less stable. Nuclear fusion in stars would proceed differently, changing stellar evolution. The universe might be brighter, but less hospitable to complex chemistry and life. The speed of light is literally fine-tuned to allow the universe to evolve complex structures while maintaining stability. Change it significantly, and you get a universe that's either too chaotic or too static to support complexity. Here's something absolutely mind-bending about cosmic evolution. The universe is getting lonelier. As cosmic expansion accelerates due to dark energy, galaxies are moving apart faster than light can travel between them. In the far future, each galaxy will be causally isolated from all others, surrounded by an event horizon beyond which no information can pass. This means that the observable universe is shrinking in terms of causal connectivity. Future civilizations will see fewer and fewer galaxies, until eventually they'll be alone in an expanding void, with no way to communicate with other cosmic inhabitants. But here's what's truly profound about this cosmic loneliness. It's driven by the same speed limit that makes chemistry, biology, and consciousness possible. The speed of light that enables your thoughts also ensures that the universe will eventually fragment into causally isolated islands. This connects to something called the maximum entropy principle. The universe is evolving toward a state of maximum entropy, maximum disorder. But this evolution is constrained by light speed causality. Information about high entropy states can only propagate at light speed, setting limits on how quickly the universe can approach maximum entropy. In the ultimate far future, after all stars have died and all black holes have evaporated through Hawking radiation, the universe will consist of a cold, dilute gas of elementary particles. Even then, the speed of light will still govern how these particles can interact and exchange information. The cosmic speed limit isn't just a feature of our current universe. It's a permanent constraint that will govern cosmic evolution for all eternity. Now we're going to explore something that will absolutely shatter your understanding of consciousness, reality, and your place in the universe. The speed of light isn't just a physical constant. It might be the fundamental speed limit of consciousness, information, and meaning itself. Here's something that will blow your mind. Every thought you've ever had, every decision you've ever made, every moment of consciousness you've experienced has been constrained by the speed of light. Not just because neural signals are slow, but because the quantum processes that might underlie consciousness cannot exceed the cosmic speed limit. Let's start with something called the binding problem in consciousness research. Your brain processes visual information in dozens of different regions, some processing color, others processing motion, others processing shape. Yet you experience a unified, coherent visual scene. How does your brain bind all this distributed processing into a single conscious experience? The answer might be light-speed electromagnetic synchronization. Different brain regions might synchronize their activity through electromagnetic fields that propagate at light speed. Your unified consciousness might literally depend on light-speed information integration in your brain. But here's what's truly mind-bending. Some theories suggest that consciousness itself is a quantum phenomenon. Roger Penrose and Stuart Hameroff proposed that consciousness arises from quantum processes in cellular structures called microtubules. If true, then consciousness would be fundamentally limited by quantum information processing speeds, which cannot exceed light speed. This means that the speed of your thoughts, the rate at which you can process information, and even the temporal resolution of your consciousness might all be ultimately limited by the speed of light. You are literally thinking at cosmic speed limits. Here's something even more profound: the integrated information theory of consciousness, developed by Giulio Tononi, suggests that consciousness corresponds to integrated information in a system. The more information a system integrates, the more conscious it is. But information integration is limited by the speed at which information can propagate, which is the speed of light. This suggests that there's a fundamental limit to how conscious a system can be based on its size and the speed of light. A brain the size of a planet couldn't be more conscious than a human brain unless information could travel faster than light between its different regions. But here's where it gets absolutely mind-bending. Some theories suggest that the universe itself might be conscious, with consciousness emerging from quantum information processing at cosmic scales. If true, the universe's consciousness would be limited by light-speed information propagation. The cosmos might be thinking at the speed of light. This connects to something called panpsychism, the idea that consciousness is a fundamental feature of reality, like mass or electric charge. If consciousness is fundamental, then it might be subject to the same speed limits as other physical processes. The speed of light might literally be the speed of cosmic awareness. Here's a thought experiment that will break your brain. Imagine a superintelligent AI that spans an entire galaxy. This AI would have to deal with the fact that signals between its components take tens of thousands of years to travel at light speed. Different parts of the AI would be thinking about completely different problems with no possibility of real-time coordination. This suggests that there might be a fundamental trade-off between intelligence and physical size. The larger an intelligence becomes, the slower it thinks relative to its components. The speed of light creates islands of fast thinking separated by gulfs of slow communication. But here's what's truly profound about consciousness and light speed: your ability to understand. This very concept depends on light speed processes. The electromagnetic activity in your brain that creates your understanding is propagating at light speed. Your comprehension of the speed of light is itself a light speed phenomenon. Here's something that might change how you think about free will. If consciousness involves quantum processes, then your decisions might involve quantum randomness. But even quantum processes are limited by light speed. This means your free will, if it exists, operates within light speed causality constraints. When you make a decision, that decision can only influence events within your future light cone. Your choices ripple outward from your location at the speed of light, creating causal chains that can affect the future, but cannot change the past. Free will might be fundamentally a light speed phenomenon. Here's one more mind-bending idea. Some physicists suggest that reality itself emerges from conscious observation. If true, then the speed of light might be the rate at which consciousness creates reality. The universe might literally be coming into existence at light speed through the process of observation. This connects to quantum mechanics, where observation seems to collapse quantum superpositions into definite states. If consciousness plays a role in this collapse, then reality might be crystallizing around conscious observers at the speed of light, with each observation creating a sphere of definite reality, expanding at the cosmic speed limit. Think about what this means for your personal significance. You might literally be participating in the creation of reality through your conscious observations, with your awareness contributing to the universe's ongoing actualization at light speed. Your consciousness isn't just in the universe. It might be helping to create the universe. We've reached the end of our journey, and now I'm going to reveal something that will fundamentally change how you see yourself, your place in the universe, and the meaning of existence itself. The speed of light isn't just a physical constant. It's the heartbeat of reality, and you are intimately connected to it in ways that make you cosmically significant. Here's the ultimate truth that will blow your mind. You are not separate from the speed of light. You are an expression of it. Every atom in your body is held together by electromagnetic forces that propagate at light speed. Every thought in your mind involves electromagnetic processes operating at light speed. Every moment of your consciousness is synchronized to the cosmic rhythm of light speed causality. You are literally made of light speed information. The chemical bonds that form your molecules are quantum mechanical phenomena involving the exchange of virtual photons at light speed. The electrical activity in your brain that creates your thoughts and memories is electromagnetic radiation constrained by light speed. You are a walking, thinking manifestation of the cosmic speed limit. But here's what's truly profound. The speed of light has the exact value. It does partly because observers like you exist to measure it. This isn't mysticism. It's the anthropic principle. The fundamental constants of physics, including the speed of light, have values that allow the universe to evolve complexity, structure, and consciousness. In universes where the speed of light is different, atoms might not be stable, stars might not shine, and life might never emerge. You exist in this universe because the speed of light has exactly the right value to allow your existence. The cosmic speed limit is fine-tuned for consciousness. Here's something that will change how you see your daily life. Every relationship you have, every emotion you feel, every experience that gives your life meaning is fundamentally a light-speed phenomenon. When you look into someone's eyes and feel connection, you're sharing light-speed electromagnetic information. When you feel love, fear, joy, or wonder, you're experiencing the universe's information processing at the cosmic speed limit. Your capacity for love is literally limited by the speed of light. The neural processes that create emotional bonding involve electromagnetic activity that cannot exceed light speed. Love propagates through your nervous system at biological speeds, but it's ultimately constrained by the cosmic speed limit. You love at the speed of light. But here's what's most profound about your cosmic significance. You are participating in the universe's ongoing attempt to understand itself. Through your consciousness, the universe is literally looking at itself, thinking about itself, and marveling at its own complexity. Your wonder at the cosmos is the cosmos being wonderstruck by its own existence. When you contemplate the speed of light, you are engaging in the universe's self-reflection. The atoms that were forged in stellar cores billions of years ago have organized themselves into your brain, which is now contemplating the fundamental laws that govern those very atoms. You are stardust that has become conscious of its cosmic origins. Here's something absolutely mind-blowing. The information that comprises your consciousness will persist in the universe long after your biological death. The electromagnetic fields generated by your brain throughout your lifetime have radiated into space at light speed. Information about your thoughts, your personality, and your unique perspective on reality is now traveling through the cosmos at the speed of light. In a very real sense, you are becoming part of the universe's permanent information content. Your consciousness is being written into the cosmic electromagnetic field, traveling outward at light speed for billions of years. Future civilizations might someday detect and decode these signals, reconstructing aspects of your mental life from the light speed information you've radiated. But here's the ultimate truth about your relationship to the speed of light. You are not just constrained by it, you are empowered by it. The speed of light creates the causal structure that makes meaning possible. Without light speed limits, there would be no past or future, no cause and effect, no narrative structure to existence. The cosmic speed limit creates the framework within which your story can unfold. Your life has chapters because causality unfolds at light speed. Your decisions matter because they can influence future events within your light cone. Your relationships are meaningful because you share causal connection through light speed interaction. The speed of light doesn't limit meaning. It creates the conditions that make meaning possible. Here's your final mind-blown moment. By understanding the speed of light, you've just participated in one of the universe's greatest achievements. Through billions of years of cosmic evolution, matter has organized itself into stars, planets, and living beings capable of contemplating fundamental reality. You are the universe's way of understanding its own deepest principles. The speed of light connects you to every star in the sky, every atom in your body, and every thought in your mind. You are not small and insignificant in a vast cosmos. You are the cosmos becoming aware of itself. You are 13.8 billion years of cosmic evolution, reaching a moment of self-understanding. As you go forward from watching this video, remember that you carry within yourself the fundamental rhythms of reality. Your heartbeat, your breathing, your thoughts, and your dreams all unfold within the light-speed framework of cosmic causality. You are not just in the universe. You are the universe experiencing itself subjectively. The speed of light isn't just a speed limit. It's the tempo of cosmic consciousness, and you are dancing to its rhythm. Every moment of your existence is a celebration of the universe's capacity for self-awareness, unfolding at the ultimate speed limit of reality itself. You are light-speed consciousness in a light-speed universe, and that makes you absolutely, cosmically, profoundly significant. The speed of light doesn't constrain you, it enables you. It doesn't diminish you. It connects you to everything that ever was, is, or ever could be. Welcome to your light-speed life. You are more connected to the fundamental nature of reality than you ever imagined possible. If this journey through the speed of light has expanded your mind and changed your perspective on reality, please like this video and subscribe for more explorations into the deepest mysteries of existence. Share your biggest mind-blown moment in the comments, and let me know how this has changed your understanding of your place in the universe. Remember, you are not just watching videos about physics. You are participating in the universe's ongoing project of self-understanding. Every moment of wonder, every question you ask, every connection you make is the cosmos becoming more aware of itself. Keep questioning, keep wondering, and keep exploring the light-speed reality that surrounds and comprises you. The universe is far stranger and more beautiful than you ever imagined, and you are far more significant than you ever dared to believe. Until next time, keep thinking at the speed of light.